Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about the algebraic properties of limits, and let's just get right into it. So, the shadow realm, part 2. Shadow is flying with the function 2/3 x plus 1 before x equals 3, and x squared minus 9x plus 21 after x equals 3. What value is he approaching near x equals 3? And we're assuming he just doesn't exist in this dimension at x equals 3. So the value at x equals 3 is undefined. So it's going to be flying. And we want to know what he's getting to really close to x equals 3. Now for this one, we know that 2/3 of 3 is 2, plus 1 is 3. So we can think that if x is getting really close to 3, then this is getting really close to 3 because the value at 3 is 3. That's called direct substitution. And it works if you want a limit that's getting close to something, you can just plug in the exact value, and it will approach that value as you approach the target x value. And x squared minus 9x plus 21, it's going to be 9 minus 27 plus 21, and that is also going to be 3. So you can think that x getting really close to 3 from the left, it's going to be getting close to 3 because of 2/3 x plus 1. And from the right, it's also going to be getting really close because of x squared minus 9x plus 21. Both of those are approaching 3. So we can say that the limit does exist, and the limit as x approaches 3 is 3. And we can actually see it from this graph here. So I have this function f of x that represents shadow's flight, and it contains those functions, and you can see it's getting really close to 3, getting to 2.9, 2.99. Well, of course, at 3, it's undefined. And there's also some important properties that limits have. So if you have functions f of x and g of x, and they're approaching a, as long as both limits exist, the normal rules of math still apply. So if you're doing addition, subtraction, multiplication, division, f of x plus g of x, it's just the limit of each of them added together, or whatever mathematical operation. Division, as long as g of x is not 0, because then you're dividing by 0 and that's no good. But then sometimes the limits don't exist. And you might think that if f of x and g of x, the limits don't exist, then the whole limit of any of these won't exist. But that's not necessarily true. Let's look at this example right here. So right here we have f of x and g of x, and we would want to find the limit as x approaches 2 of f of x times g of x. Now, the individual limits clearly don't exist. There's this big jump. Like, you think about an eagle, it wouldn't be able to fly normally. It's a big jump. The limit doesn't exist. So then we would have to look at the limits from the left and the right. So if f of x is getting really close to 2, you can see that x is approaching 2, f of x is approaching 2. So that limit from the left is going to be 2. And this one is just kind of staying down here right at -2. So we're saying that limit is going to be -2 as well. So limit from the left, 2 times -2, -4. Now limit from the right, f of x is going this nice straight line right here. and it's going up and up and up. It's getting really close to 4. And g of x, you have this line down here, staying pretty consistent at -1. So you're going to say that limit's -1. And the limit from the left is going to be -1 times 4, which is also -4. So you'll notice that if you take the limit from the left and the limit from the right, they both approach a common value, which is -4. So this limit, f of x times g of x, as x approaches 2, actually does exist, and it's -4. Now that's it for today. Let's see you next time.